The first Shermans rolled off the landing craft onto the beaches of Normandy in June 1944, engines coughing seawater and sand. Many of them would burn before the day ended. German anti-tank guns waited behind hedgerows and stone walls, firing from hidden positions. Panthers sat farther back, using the long reach of their cannons to strike before the Americans even saw them. To German crews, the battlefield looked like proof. The American tank was weak. It burned easily. Its guns struggled against German armor. Everything they believed about engineering seemed correct. But far from the beaches, in quiet rooms filled with blueprints and reports, another story was already written. More than a year earlier, in April 1943, a captured American tank had arrived at Kummersdorf, Germany's primary weapons testing facility. It had been abandoned during the fighting in Tunisia and recovered almost intact. The tank's serial number was recorded. Its components were photographed. German engineers expected to find shortcuts, poor steel, careless welds. Instead, they found consistency. Welds were uniform. Plates were measured to identical tolerances. It did not look like a machine built by craftsmen. It looked like a machine built by factories. The armor was not impressive by German standards. The gun was not powerful. But the engineers noticed something that was not in the firing tables. The engine could be reached easily. Panels opened without special tools. Components could be removed without dismantling half the vehicle. The transmission used helical gears, quieter and longer lasting than the straight-cut gears used in German tanks. These gears required precision tooling and materials Germany struggled to obtain under blockade. The Americans had them in abundance. One engineer wrote in his report that the tank seemed designed not for victory in a duel, but for survival across distance. It was meant to be driven for hundreds of miles, repaired in the field, and returned to service by ordinary mechanics. German tanks were built for battle. American tanks were built for travel. At the proving grounds, the Sherman was tested against a Panther. On a sandy slope, the German tank climbed with ease while the American tank slipped and slid backward. The generals applauded. The demonstration appeared to confirm German superiority. The engineers remained silent. They were not looking at the hill. They were looking at the transmissions. The Panther had won the climb, but its final drive was fragile. The Sherman had lost the climb, but it had crossed an entire desert under its own power to reach German hands. When Albert Speer, the Minister of Armaments, reviewed the reports, he understood what most of the generals did not. Germany built machines that required railways and factories to survive. America built machines that could move themselves to war. The Sherman was not just a tank. It was a product of a different industrial philosophy: reliability over perfection, maintainability over elegance, quantity over uniqueness. By the time Allied forces landed in France, the consequences of those choices were beginning to appear. Sherman units suffered heavy losses in the hedgerows. Panthers dominated long-range engagements. Tigers terrified infantry. Yet behind every American loss stood a system designed to absorb it. Ships unloaded tanks in ports. Trains carried spare engines inland. Trucks delivered fuel and ammunition without pause. A destroyed Sherman was replaced. A damaged Sherman was repaired. A crew that survived was sent forward again. German units did not enjoy this cycle. Panthers required specialized parts and trained mechanics. Tigers required cranes and workshops. Fuel shortages forced crews to abandon operational vehicles. Air attacks broke supply lines. A tank that could defeat several enemies meant little if it could not be moved or sustained. As the campaign pushed inland, the terrain favored movement. Shermans crossed bridges Panthers could not use. Their lighter weight reduced strain on roads and tracks. They consumed less fuel. They could march for days with only routine maintenance. Their crews trusted them to start in the morning. German crews often did not. In Normandy, American tank crews adapted. They welded scrap metal and spare track links onto their hulls. They mounted logs to their fronts to break through hedgerows. They modified their machines with whatever was available. The Sherman's design allowed this. It did not demand precision. It accepted improvisation. German tanks were too refined to tolerate such changes. Their systems were tightly integrated. Field modifications risked damaging them further. Reports from the front showed a strange pattern. German tanks destroyed more enemy vehicles per engagement. American tanks appeared in greater numbers after every engagement. German victories were tactical. American victories were operational. In August 1944, as German forces retreated from Normandy, their heavy tanks crowded narrow roads. Fuel trucks were destroyed by aircraft. Panthers were abandoned with full ammunition but empty fuel tanks. Crews set explosives and walked away. The Shermans advanced through villages and fields, often damaged, often repaired, always moving. The war was no longer decided by which tank could kill the other. It was decided by which tank could keep moving. The German engineer followed these developments through reports. He saw statistics that did not appear in propaganda films. Operational readiness rates dropped below 50%. More than half of German tanks were out of action at any time, not because of enemy fire, but because of mechanical failure. American readiness remained above 80%. When the Americans needed tanks, they had them. The Panther's gun was superior. Its armor was thicker. But its transmission failed after short distances. Its engine overheated. Its parts were not interchangeable without adjustment. Each Panther was a masterpiece. Each Sherman was a copy. Factories in the United States produced tanks as if they were automobiles. Workers repeated the same tasks every day. Parts fit without filing. Engines were swapped in hours. In Germany, skilled workers hand-fitted components. Precision was achieved through labor, not tooling. It produced excellence, but it could not produce speed. The war became a contest between two clocks. One measured how fast a tank could be built. The other measured how long a tank could be used. When the Ardennes offensive began in December 1944, German armored units advanced with their last reserves. Panthers and Tigers broke through American lines in the opening days. Shermans were destroyed in forests and villages. The German command believed this was proof that quality still mattered. But winter revealed what summer had hidden. Engines failed in the cold. Fuel ran out. Roads collapsed into mud. German tanks became trapped by their own weight and complexity. Shermans, simpler and more forgiving, continued to operate. Their engines were easier to service. Their parts were available. Their crews had supply. The offensive collapsed not because German tanks were defeated in battle, but because they could not be sustained. By early 1945, the contrast was absolute. German units reported victories and breakdowns in the same sentence. American units reported losses and replacements. One side lost machines, the other lost time. The engineer remembered the first Sherman he had examined. It had looked crude compared to German designs. Now he understood its purpose. Its weaknesses made it mobile. Its simplicity made it replaceable. Its ordinariness made it unstoppable. The Panther was designed for a battlefield of control and superiority. The Sherman was designed for a battlefield of chaos and distance. The Panther assumed secure railways and factories. The Sherman assumed oceans and mud. As Allied forces crossed the Rhine, Panthers appeared rarely. They fought hard and died alone. Shermans rolled forward in columns. They did not need to win every duel. They needed to keep pressure on every road. The war of tanks was becoming a war of exhaustion. Germany had built machines to dominate the enemy. America had built machines to outlast him. And somewhere between steel and fuel, between factories and front lines, between engineers and drivers, the outcome was already decided, not by who built the better tank, but by who built the better system. The engineer no longer thought of the Sherman as an inferior design. He thought of it as a message. It said that the war would not be won by brilliance, but by endurance. Not by strength, but by continuity. The battlefield still burned. The reports still listed victories and losses. But beneath the smoke, the mathematics of production and repair continued their quiet work, shaping every movement, every retreat, every advance, and the tanks kept rolling. By the spring of 1945, the German armored force no longer resembled the weapon that had once swept across Europe. What remained was a collection of powerful machines scattered across a collapsing infrastructure. Panthers and Tigers still existed on paper, but many could no longer move. Rail lines were shattered by bombing. Fuel was rationed to the last drop. Crews received orders they could not follow, not because they lacked courage, but because their tanks could not reach the battlefield. American armored divisions advanced across Germany with a rhythm that no longer depended on victory in individual engagements. Shermans rolled through ruined towns, across damaged bridges reinforced with wooden planks and steel plates. When a tank broke down, another took its place. When a crew was lost, another arrived. The movement never fully stopped. The war had become less about destroying the enemy and more about denying him time to recover. The German engineer who had once examined the captured Sherman in 1943 followed the final campaign through reports that arrived late and incomplete. He read about battles that lasted hours and retreats that lasted weeks. He read about tanks abandoned not because they had been defeated, but because they could not be fueled or repaired. The Panther's gun could still destroy a Sherman at long range, but range meant little when the battlefield itself was shrinking. The American tank was everywhere. The German tank was wherever it could still be kept alive. The final encounters between German heavy tanks and American medium tanks often ended the same way. A Panther would appear at the edge of a village, destroy one or two Shermans, and then withdraw when artillery or aircraft approached. It was no longer hunting. It was surviving. The Sherman crews learned that they did not need to charge the enemy's strongest weapon. They only needed to force it to move, to fire, to consume fuel and spare parts that no longer existed in abundance. The war between tanks had become a war between supply systems. Factories in the United States still produced Shermans in numbers that exceeded losses. Engines were shipped in crates. Tracks were shipped by the ton. The American tank did not represent a single machine. It represented an industrial rhythm that could not be broken by battlefield success alone. Germany, by contrast, had reached the limit of its capacity. Each new Panther cost more than the last, not in materials alone, but in time. Skilled workers were gone. Power plants were damaged. Railroads were cut. The Panther was becoming a museum piece before the war had even ended. When American and Soviet forces closed in from west and east, German armored units found themselves unable to concentrate. Tanks were scattered, waiting for fuel that never arrived. Crews stripped parts from one vehicle to keep another moving, but this only delayed the inevitable. Every operational tank represented 2 or 3 broken ones behind it. The engineer saw this clearly in the numbers. Operational readiness had fallen below 30%. The remaining machines were being consumed faster than they could be restored. In April 1945, American Shermans reached the Elbe. They crossed rivers on pontoon bridges built overnight. They climbed hills that had never seen tanks before. Their engines ran continuously, stopping only for refueling and routine checks. They did not appear as symbols of technical superiority. They appeared as tools of movement, carrying infantry forward and forcing the war toward its end. The German engineer thought again of the hill climb test at Kummersdorf 2 years earlier. The Panther had won that demonstration. The Sherman had failed. The generals had applauded. He now understood the mistake. They had tested for strength, not for survival. They had measured what a tank could do once. They had not measured how long it could keep doing it. Germany had built tanks for the battle it wanted. Decisive, controlled, short. America had built tanks for the war that existed. long, chaotic, and mechanical. The final statistics confirmed what the battlefield had already shown. German tank crews achieved high kill ratios. Their guns and optics were superior. Their armor was thicker. Yet these achievements could not change the arithmetic of war. A Tiger might destroy several Shermans in a single engagement, but there would be more Shermans tomorrow, and the Tiger would likely be waiting for fuel, for parts, or for a road that no longer existed. The American tank did not win because it was feared. It won because it was present. By the time Germany surrendered, the wreckage of its armored force lay scattered across forests, fields, and roadsides. Panthers with broken final drives, Tigers with empty fuel tanks, guns still capable of firing, but no longer part of a system that could support them. Nearby, Shermans also lay burned and twisted, but behind them stood the factories and supply lines that could replace them. History would later argue over which tank was better. Engineers would debate armor thickness and gun penetration. Veterans would remember fear and fire. But the engineer who had touched the hull of that captured Sherman understood something simpler. The war of tanks was never truly about tanks. It was about whether a nation could turn steel into movement faster than the enemy could turn movement into wreckage. Germany built masterpieces. America built momentum. One side created machines that dominated the battlefield. The other created machines that dominated the calendar. And in a war that lasted years, not moments, the calendar was the most powerful weapon of all.